Hi everyone and welcome. Today we're going to be talking about power laws. But before we get into that, we're going to start by talking about the different parts of a power just so everyone can be on the same page about vocabulary. So to begin, we have the base of the power, and that's the bit that's in red. And this base is raised to an exponent, which is in green. And together the base and the exponent, they make up the power. So another part of it is the coefficient, which is separate. It's separate from the power, and we're not going to be talking about it too much, but it's an important piece of vocabulary to get down. And the coefficient is whatever the power is being multiplied by. So that's the number 2 in yellow you see there. Okay, so moving on to the actual power laws. So first off, we have the rule about multiplying powers. So what happens in this rule is that whenever you're multiplying two powers with the same base, you will add the exponents together. So in this case, we have x to the a times x to the b, and that's going to be equal to x to the a plus b. So in our example over here, we can kind of work through the multiplying power rules. So the first step is to kind of separate it out. So we see that we have these two x's, underlined in light blue, and then the 5 and the 6. So we can multiply the 5 and the 6 together, which, as you know, gets us 30. Next up, we can multiply the x squared and the x cubed together, which is going to get us x to the 2 plus 3, or x to the 5. Okay, pretty easy. So moving on, we have a very similar concept, and that is the dividing powers. So in this case, we have x to the a divided by x to the b, and that's going to be equal to x to the a minus b. So similarly to what we did in the last example, we're going to start off by separating it out. So we have the 4 and we have the 2, and our first step is going to be divide the 4 and the 2. So that gets us 2. Next up, we have the x's. So x cubed, and then just x. And whenever you have just x, you can pretend that it's actually x to the 1. It means the same thing, it's just a little easier to write it without the 1 up there. Anyways, so now we're going to be subtracting the exponents of those powers. So it's going to be x to the 3 minus 1. And that gets us 2x squared. Okay, so now a bit of a different kind of a power law. We have the power of a power rule. So in this case, we have x to the a raised to the power of b. And to figure out what that would be in the simplified form, you multiply the powers together. So it would be x to the a times b. Okay, so now our example. For our example, we have x squared raised to the power of 3. So we're just going to multiply the 2 by the 3, and that gets us x to the 6. Okay. So important things to remember when you are using power laws is that if you want to divide or multiply the powers, the bases of the power need to be the same. So for example, x squared times y squared does not equal x times y all raised to the power of 4. That's just incorrect. If you have a similar situation, but this time without variables, instead we have actual numbers in there, and we have 4 squared times 2 squared, that also does not equal 8 to the 4. Again, incorrect. That will definitely mess you up in your math. Okay. So some other kind of related rules to powers is we have the negative exponent. So in this case, we have x raised to the negative 1. And what you do there is you just kind of invert the power. So you're going to end up with 1 over x to the, again, we can write it as x to the 1, or you can just leave it as x. So now an example, we have x to the negative 5. And that's just going to be equal to 1 over x to the 5. So pretty simple. Okay, and now any time that we have a base with an exponent 0, it's always going to be equal to 1. So it doesn't matter what the base is, it's going to be equal to 1. So 5 to the 0, it's just going to be equal to 1. Something important to note, that if you have a coefficient on this, so let's say you have 2 times 5 to the 0, it would, first up, because we're following the rules of BEDMAS, you're going to evaluate the exponent first. So that gets you 2 times 1, which is equal to 2. So just don't forget to multiply it by the coefficient. That's very important to remember to do. Okay, so now we're going to do a bit of a tricky example just to combine all of the things that we've learned today. So again, we're going to need to make sure that we follow the rules of BEDMAS. I'm just going to write them over here on the corner just so we can all remember. Okay, so first up, we are going to be dealing with this part over here. So, we have to distribute that 2 that everything's raised to first, before we can do anything else. Okay, so let's take a look at what that's going to look like. So we're going to have 5 squared times x, and we are going to be using the power of a power rule over here, so that's going to be x to the 4, because we're multiplying them together. And then y, again, it's going to be power to the power, so that gets us y to the negative 6. So all of that, we still have the rest of the equation we have to write out, so let's just do that quickly. X, y, and z, and then all of that's being divided by 2 times x to the negative 1 times y squared. Okay. So the next step that I think is important to do is that we're going to deal with these negative exponents. So, again with the negative exponents, what you have to do is you have to move them into either the denominator or the numerator. So this x to the negative 6, that'll get moved down to the denominator, and the x to the negative 1 up to the numerator. So let's write this out. Also at the same time, we can just evaluate this 5 squared, which is going to be equal to 25. So we have 25 times x to the 4, that's staying there. The y to the 6, it's going to be moved down here. So that's all dealt with. We can give it a little check mark. And then multiplied by x, y, z. Okay. And then in the denominator, we're still going to have that 2 down there. But that x to the negative 1, it's going to get moved up to the top. So we have an additional x in our numerator. So that's also all dealt with. And then we have another y squared in the denominator. Awesome. So our next step is just going to be to gather all of the powers with the same base in the numerator and the denominator. So let's start off with our numerator. So we can, just to make stuff easier, use different colors to kind of look at the different values that we have. So first up, let's do x's, and I'm going to underline them in red. So we have x to the 4, x, and another x. Okay, so that's going to be equal to 25. And now don't forget, we are multiplying, we're using the multiplication rules. So that means we're going to have to add the exponents together. So we're going to have, so we have x to the 4 plus 1 plus another 1. So that gets us x to the 6. Okay, so now let's look at our y's and our z's. So we only actually have in our numerator 1 y, underlined in yellow, and 1 z, underlined in green. So we don't have to worry about those. So we can just put them in the equation. Okay. So now we can worry about our denominator. So let's take a look at that. So in our denominator, the only variables we have is 2 y's. So underlining those in yellow. And then we have a 2. So we can just start out by writing out the 2 in front. And then we can, again, use our multiplying power rules to figure out what y to the 6 times y squared would be. And that's going to be y to the 8. Again, because we are just adding the exponents together. Okay, So we've gathered all of them together now in the numerator and the denominator. So we're going to simplify it further by using our dividing power rules. So if we look at it, we have, highlighted in red, one term with an x, two terms with a y. Oh, I should have used another color. Sorry. Two terms with y's, and one with z's. So, and we can also divide our coefficients. So this is going to be equal to 25 divided by 2, which is 12.5, multiplied by x to the 6. Again, there's nothing else we need to do because there's no other x's in there. And then we have our y's. So we have y to the 1 in the top of our equation, and then y to the 8 in the bottom. So we're going to have to subtract 8 from 1. So that gets us y to the -7, and then we have a z. Awesome. So this is about as simplified as it gets, but teachers often like you to show your response with no negative exponents, which means we have to get rid of that little situation there. So pretty easy. We're just going to move that into the denominator of our equation. So we have 12.5 times x to the 6 times z all over y to the 7. And that's all. So I hope that this video has helped you to hopefully understand the power rules a little bit better. And yeah, thank you for listening.